So in this session, we are going to see about radicals, and we are going to dive in deep into some of the concepts of radicals, how radicals are formed, and why they are having that particular charge. So everything about radicals in this session, please pay attention. Okay, so let's start with like sulfate. Okay, sulfate, sulfite, and sulfide. First of all, what are radicals? Radicals are those, you can say, group of atoms or atoms which are having a charge, which are unstable and which are having a particular charge. They are called as what? Radicals. Okay, so what is the sulfate radical? Sulfate radical is SO4 2 minus. Sulfite, now always remember 8 and 8. See, chemistry is a very sensitive subject. Chemistry is a very sensitive subject. Why am I saying this? Because even if you change one letter, A you change to I, okay, 8 you change to 8, there will be change in the formula, and there will be change in the formula of the radical. So 8 was having 4 oxygen, 8 will always, any of the 8 and 8, like sulfate, sulfite, nitrate, nitrite, carbonate, well, although there is nothing like carbonate, but phosphate, phosphite, all of them will be having, 8 will always have 1 oxygen more than 8. In other words, 8 will always have 1 oxygen less than 8. And what will be ide? Again, we have changed only one letter, T we have changed to D. So ide is the element alone with its own valency. Is the element alone with its own valency. That is ide, sulfide. So have a look at sulfate, right? Okay, first I'll just make the list. Sulfate, sulfide, sulfide. Then let's go for phosphate. Now phosphate 8 is what? PO4 3 minus. Okay, now we're going to also see why only 3 minus, why not 2 minus, why not 1 minus, why not 4 minus, why only 3 minus, that we are going to have a look at. So next is phosphite 8 8 will have 1 oxygen less with the same valency. And phosphide, okay, phosphide ide need not have the same valency, it will be the element alone with its own valency. It's just a coincidence over year and year that the valencies are same. Okay, so phosphate, phosphite, and phosphide. Then we go for nitrate, nitrite, and nitride. Okay, nitrate, nitrite, and nitride. Okay, so nitrate is NO3 minus 1. So you must have guessed by now that nitrite is going to be 1 oxygen less with the same valency, NO2 minus 1. And what is nitrite? The element alone with its own valency. So what do you mean by its own valency? Right, nitrogen is having an atomic number of 7, electronic configuration 2, 5, requires 3 more electrons to complete its octet. That's why minus 3 is the valency of nitrogen. That's what we write in case of ide. So same goes for phosphide, P minus 3, sulfide, S minus 2. Then we can also go for carbonate. And as I told you, carbonite will not exist. We'll directly move on to carbide. Okay, so carbonate is like CO3 minus 2, carbide C minus 4. Okay, now let's see how they are forming these particular charges. Like sulfate, let me draw the structure of sulfate. Before I draw the structure of sulfate, let me write the atomic number of sulfur, which is 16, and electronic configuration 286. So sulfur having the structure, sulfate having this structure in this format. So have a look. Sulfate is having 6 electrons in its outermost shell, and oxygen being the world's second most electronegative element, oxygen is pulling electrons from sulfur. It's forming a polar covalent bond wherein oxygen is pulling a greater share of electrons. So sulfur has given like 2 electrons to this oxygen, 1 electron to this oxygen, 2 to this one, 1 to this one. So oxygen, tell me, having an atomic number of 8 with an electronic configuration of 2, 6, it wants 2 electrons to complete its octet. Minus 2 is the valency of oxygen. Okay, so oxygen wants 2 electrons. That means this oxygen wanted 2 electrons, it has got 2 electrons, it's very much satisfied, it's happy, right? Then again, this oxygen, it wanted 2 electrons, it has got 2 electrons, it is also happy, right? But what about this oxygen and this oxygen? They wanted 2 electrons, but instead of 2, they have got only 1 and 1 electron, due to which they generate a charge of -1 and -1. Say for example, you are hungry, and the hunger is for 2 chapatis. So if instead of 2 chapatis, mama gives you only 1 chapati, then what you will do, you will raise your hand, -1 charge, I want 1 more chapati. Okay, are you understanding this? So that's the reason why sulfate is SO1, O2, O3, O4. SO4 -1 and -1 will become -2. That is sulfate -2, SO4 -2. Okay, that's why it is -2. But this minus charge is not going to be for a very long time. Okay, this minus charge will be satisfied by anybody who's ready or willing to give an electron. Okay, so say for example we are having sodium is ready to give one electron because valency is 281, valency is +1, electronic configuration is 281. So it's ready to give one electron to oxygen, and it will give, and one oxygen will give electron from here. And that's what we learn in crisscross, isn't it? Right? We cannot draw the structures all the time, so what we do is we try to do crisscross, like the two will come over here, one will come over here, and we'll get Na2SO4. What will we get? Na2SO4, sodium sulfate. Okay, sodium sulfate, Na2SO4. Okay, now we'll go for nitrate. Nitrogen having a valency of -3 or 5 electrons, with 5 electrons in the outermost shell. So this nitrogen, when it is forming nitrate, it can give at the most 5 electrons to oxygens, right? So this oxygen has got 2 electrons, it is satisfied, it's happy. This oxygen has got 2 electrons, but unfortunately this oxygen has got only 1 electron, so it will show a charge of -1. So nitrate is NO1 O2 O3 NO3 -1, nitrate NO3 -1. Then if you want to go for phosphate, phosphate will be with phosphorus, right? So phosphorus atomic number 15, electronic configuration 285, 5 electrons in the outermost shell. Here we are having P double bond O -1, and O -1. So phosphorus has 5 electrons to donate, 1, 2, this oxygen is satisfied, but 1, 1 and 1 electrons to these 3 oxygens, they're not satisfied. They're showing -1, -1 charge. So PO1, O2, O3, O4, PO4, and -1 will become -3. That's why phosphate is PO4 -3. Then talking about carbonate, carbonate is CO3 -2, as we have seen earlier. Why is it CO3 -2? Because of its structure, because of the valency of carbon. What is the valency of carbon? 4. So it has given 1, 2, 3, 4 electrons to the oxygens, out of which these two oxygens have not received a pair of electrons, due to which they generate a charge of -1 and -1. So it becomes a total of CO3, CO1, O2, O3, -1 will become -2. CO3 -2 is the formula for carbonate. Okay, so this is how you understand what are radicals, and why do they form that particular charge. How to satisfy them? By combining them with the positive radicals. All of the radicals which we have seen were negative radicals. When you combine them with positive radicals, they get electrons from metals and they become a compound. Just like we had seen sodium sulfate, we can also combine, say for example, carbonate with calcium, like Ca plus 2 CO3 minus 2. 2 will go over here, 2 will go over here, so Ca2 CO3 twice. So this 2 and 2 will cancel, and the final answer will be CaCO3, calcium carbonate. This is how you can form compounds.